Hi everybody, this is Julie and I'm going to discuss using default arguments and function overloading in C++. So I'm first going to talk about default arguments and how to use them. Then I'll talk about function overloading. And these are both great things that we can do with functions to enhance how they work, but these two features do not work well together. So first, let's begin with default arguments. If you have a function where one or more of the parameters almost always has the same value, you can set it up to have a default. Then when you call the function, you don't have to provide a value for that parameter, and the function will use the default. The only place where we program this is in the function header. In the body of the function, it has no idea that a default was used. So let's take a look at a function here. This function is called calculateTax, and it has two parameters. They're both doubles, named price and rate. And because most of the time when I calculate sales tax, I'm going to use the same sales tax rate, I set this up to have a default value of 0.0825. And then the function is just going to simply multiply price by rate and return the product. Well, when I call it, I could choose to call this only with a variable or a value for the first parameter. So now when I call calculateTax, I'm only passing 1,000 to it. 1,000 will be used in the price parameter, and then rate will be set to 0.0825. Or I can still call this function with a value for the tax rate by just including a second parameter. So in the second example, I'm providing price and a different tax rate of 0.0625. When this function gets called, it will ignore that default because I'm providing a particular value. And then I can see when I execute this program that the first one came up with a tax of $82.50 and the second one $62.50. Now, there are some things to be careful about with default parameters. Once you set up a default, everything in the list has to also use a default. So in my function header, I can have a function getSum that has 3 parameters of all integers. And if I want, I could set 2 of the 3 variables or parameters to default to 0. So if the first one doesn't have a default, I can then default the second and third one. But in the second example, I'm only setting a default on the second parameter. And this won't be allowed because I will have to also set a default with the third. The same is true when I'm calling the function. This function getSum, the one at the top, can be called with either 1, 2, or 3 parameters. And so my first call to getSum is using 2 parameters. That's going to be fine. I'll copy the value of num1 and num2 to the first 2 variables, and I'll use a default for the third. Or if I try to call it by omitting the second value, that won't be allowed because once I omit a variable, I have to omit all the remaining variables. The other thing I want to talk about is overloading functions. And an overloaded function is just a function, well, it's really 2 or more functions that happen to have the same name. But they will have a different parameter list. Then that different parameter list can be different either by having a different number of parameters or one of the more parameters can have a different data type. We see a lot of overloaded functions in object-oriented programming. So what does this look like? Well, here I have my first function, calc area. It has two doubles as parameters, and it's going to multiply them together to calculate the area of a rectangle, length and width. But I could create a second function for squares, also called calc area. This time I'm only going to provide one value. And then in the body of the function, I'm going to do a different calculation. I'm going to take the value that's passed to the function and calculate the value squared. So these two functions have the same name, but they have a different parameter list. The first one has two parameters, and the second one only has one. So now, when I want to call the function, the first example here, I have a variable side1 that's set to 5, and side2 is set to 4. I'm going to call calc area with both of those values, and the value I will get back will be 20, or 5 times 4. But if side 1 was part of a square, then I wouldn't call it with a side 2. I would only call it with side 1. And this time when I call calc area, I'm not calling the first calc area, I'm calling the second calc area. The second one is called, the value 5 is squared, and 25 is returned. So, again, this is something that you do want to be cautious about, and don't mix these two techniques. Function overloading does not work well with default parameters. And the reason is, when we have default parameters, we can call one function with a different number of parameters, and this can get very confusing for the compiler. The compiler has to know exactly which function to call and which one matches your parameter list. So either use function overloading or default parameters, but it's difficult to use them both simultaneously. All right, so let's review here. If two functions have the same name, what must be different? And that's going to be our parameter list, either the number of parameters or one or more data types. And how does the compiler know which function to call? It's going to look for the best matching parameter list. So that can either be a function with a default value where we're not providing all of the parameters, or it can be with function overloading where we're going to choose the function that has that same parameter list.